You slide a pencil toward your lab partner with a speed of 4 meters per second. Your lab partner misses the pencil and it slides off your desk where it hits the ground 1.8 meters away. How high is your desk off the floor? Our picture is drawn up here. Here's our desk. That's the pencil. It's going to hit the ground 1.8 meters away from the desk. So that's distance in the X direction. We're trying to figure out how high the desk is. So that's going to be the displacement in the Y direction. Everything in black is going to live in the X. Everything in red is going to live in the Y. So in the X direction, we know the velocity is going to be 4 meters per second because you slide it across the table. So that's the speed it has as it leaves the table, and that's going to be in the X, left and right direction. So 4 meters per second there. And we know that it's going to land 1.8 meters away, and away would be another X direction thing. So 1.8 meters for the X direction. In the Y direction, we have a couple of numbers. We know that the acceleration for anything that's a projectile is going to be negative 9.8 meters per second squared. We know we're trying to figure out how far it's going to fall, so that's our question mark, is D in the Y direction. And we also know that since it's being sort of launched horizontally, the initial speed in the Y direction is going to be 0. We don't have enough information in the Y to solve for D, but we can get time in the X and then use it in the Y, so that's what we're going to do. X is constant velocity motion, so we're going to use our constant velocity equation, D equals V times T. So now if I rearrange this equation for time, I have to move the velocity over. That gives me D over V equals time. Plugging our numbers in, 1.8 meters divided by 4 meters per second. And that's going to give us a time of 0.45 seconds. So that's how long it's going to take the pencil to leave the desk and hit the floor. We can use that in the Y direction. And now pick the equation without VF in it to solve for D. That'd be the third equation, D equals V naught T plus 1/2 A T squared. It's already arranged for what we want. V naught is 0, so this term is just going to cancel and go away. So D equals 1/2 A T squared. I can plug in some numbers. 1/2 times negative 9.8 meters per second squared multiplied by 0.45 seconds. And I square that. Plug all of that into my calculator, and I get negative 0.99 meters for the height of the desk. Why is it negative? Because technically we solved for the displacement of the pencil, which was downward. So the negative makes sense in terms of the displacement of the pencil. If we were just saying how high is the desk, you could leave the negative out. Either way, I would mark that correct on a test, as long as you understood what the heck you were trying to solve for.